Hello and welcome to everyone out there in the Actual Tech Media audience. Thank you so much for joining us on this webinar. Today's topic, why every enterprise needs a cold data storage strategy. This event is presented in partnership with our friends at Quantum. We've got a great presentation lined up for you today. Before we get started, there's just a few things that you should know about today's event. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. As always, we want these events to be educational, and we encourage your questions there in the questions pane. We will be taking your questions live at the end of the event, but as you think of a question during the presentation, please drop it there in the questions box. We even have a best question prize to help encourage your questions. So thank you in advance for those. We're all former IT professionals here at Actual Tech Media. We know how tough it can be out there in the world of IT. You've got a lot of challenges, and hopefully you'll find some great solutions on this webinar today. We've got some handouts as well. I encourage you to check out there in the handouts tab. There are resources on the quantum active scale cold storage solution and a report from IDC on data deluge, why every enterprise needs a cold storage strategy. At the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card. Make sure that you stay tuned for that, of course, as well. If you're watching this on demand, that drawing would have already occurred. The prize terms can be found right there in the handouts tab. And then we also have our best question prize for an additional Amazon $50 gift card. If you ask the best question on the event today, we will contact you via email after the event with that additional gift card prize. Of course, you have to ask a question to be entered into the drawing. All right, so with that, it's time to kick off today's webinar. I'm excited now to bring in Mr. Eric Basier, Senior Director of Product Marketing at Quantum. Hey, Eric, it's great to have you on.
Yeah, great to be here, David, and thanks for having me.
Absolutely. Take it away.
Excellent. Well, thank you, and thanks to all that have joined us today. As David said, what we're going to be talking about today is why every enterprise needs a cold data storage strategy. And I want to start with kind of the summary of what we're going to be talking about. Data growth is just far outpacing storage budgets. I think many of you are probably living that. The other big dynamic we're seeing is with the growth in AI and machine learning and the type of data sets that are needed to drive those initiatives forward. The way that data is used and reused is changing. So how can enterprises solve for that budget gap and at the same time have an infrastructure that supports those types of initiatives, that enables those types of initiatives? And the answer lies in a cold data storage strategy. And I'm going to talk about what is cold data, why is it growing, I'll kind of define it. And according to IDC, and I would say all the other analysts have this same perspective, about 60% of all the data being generated is cold. So how do we think about that data? How do we think about managing that data differently? And so what I want to talk about is explaining a little bit more about what we see in the market, kind of what we see happening. And then I do want to talk about a new as a service offering that we've just introduced that I think can help. First, I want to talk just a little bit about Quantum. I'll go through the corporate stuff quickly. But our mission is to be the leader in end-to-end solutions for video and unstructured data. Many of you are probably familiar with Quantum. The company's been around a long time. Over the last few years, we've really transformed our portfolio and our mission to be able to focus on this. Now, why is this our mission? Why is this so important? First, 90% of all the data on the planet is unstructured. Now, unstructured data it's big files. Most of it is different forms of video and digital images. A lot of this is shown here. This might be video for surveillance purposes, which as part of a smart city initiative, that video may be used to analyze traffic patterns. It might be video for entertainment and communications purposes. Many of us we know how pervasive video is in our day-to-day lives, and probably many of you within your enterprise or your organization, you use video on a daily basis. And then there's a whole bunch of different forms of data that we would categorize as different forms of digital imagery. This might be data coming off of a self-driving car or a robot. A lot of machine vision initiatives are based on this type of data because we have to teach a machine to see, right? Satellite imagery, life sciences data, MRI images, CAT scan images, data coming off of a genomic sequencing machine. These are all forms of digital images. And it really is this data that is at the center of most digital transformation initiatives. Now, unstructured data is a little bit different than, say, a database or VDI. It's often, products are built with this type of data. Businesses are run on this type of data, and it has a unique life cycle. It has a life cycle that's different. Typically, data is created by a machine of some type. You can see some of the images here, right? It might be a camera, might be a drone, an MRI machine, etc. It typically gets analyzed at some point, and then it gets uploaded. It goes through a stage in its life cycle where that data is initially it's cataloged. It gets worked on, right? Some product gets produced, and in this stage, you could think of the data as being really hot, right? Speed is really important here. Speed to ingest the data, to process it, and also to allow a whole bunch of different people, typically highly skilled, highly paid people, to collaborate on that data to produce some product. And this is where data orchestration really is centered or starts to take place, right? When many of our customers are, large television studios or movie studios, they're going to have different editors, producers working on that content at the same time. And then when they're done working on it, they want to move it somewhere else. They may want to distribute it, right, over the internet or something, or they may want to move it to the cloud for archiving. So it has this stage of, where high performance matters. And then for a lot of this data, what we're finding is when companies are done working on it, they want to keep it not for, 6 months or 7 years for compliance purposes. They want to keep it for multiple decades because it has value and it's going to be reused. Think about keeping MRI images for the life of a patient. Think about if surveillance footage is used in a case, it often has to be kept for many decades. Obviously, movies and TV shows, that's a good example, but we're even finding with many of our customers that have machine learning initiatives, they want to save those training models for a long time so that they can go back. They may want to retrain using those old models. So at this last stage, this is really cold data. And I think what matters here is massive scale, being able to store a huge amount of data cost effectively for many years and in some cases decades, but make it accessible for reuse and make sure it's built on a cyber resilient infrastructure. So a little bit on Quantum's portfolio that we've built, it really maps against that life cycle. We have everything from asset and workflow management software that can analyze, enrich, and orchestrate this type of data, to high-speed parallel file system software, hyper-converged infrastructure for mission-critical surveillance workloads. And then when it comes to archiving and backup, we have an object store system in ActiveScale, and we have tape. And I want to tell you a little bit more about tape, which is something that Quantum has been known for many years. But an interesting thing happened in the tape market several years ago. One of the world's biggest cloud providers came to us and said, I have a problem and I need tape. And we've quietly over the last several years become the leader in providing tape infrastructure to some of the world's largest hyperscalers. Right now for Quantum, 5 of the top 5 hyperscalers are customers. We've got over 30 exabytes of tape storage deployed in hundreds of data centers around the world. And more recently, we've started to sell systems and solutions to I would call them Webscale companies. So they're not in the top 10 in the world, but they're probably in the top 100. I'll give you a couple of examples of this. One is a large social media company. And what they wanted to do was they wanted to build a large data archive of all of the social media data that they had to store. So predominantly, when we think about social media, predominantly video, different forms of images. And the initial footprint for them was over 2 exabytes, right? So again, this data has massive scale and they want to keep it for many, many decades, right? That's part of their business. And so we've kind of learned how to deploy tape at hyperscale at these major cloud providers. But these cloud providers have the internal resources to develop their own software stacks in many cases, right? If we think about cold storage services offered by the public cloud like AWS Glacier or Azure Cold Storage or Google Archive Storage, these are services that have been built by these public cloud companies. What we want to do is we want to take our expertise, take the architectures and the technologies that we've used here, but now be able to package that and offer it to the enterprise. So what was their pain point? I mean, why did they employ a cold storage strategy, and why do we think every enterprise needs a cold storage strategy? And it's really these two data points that go together. And this is based on some research that IDC has done that we've partnered with them on. And one of the resources that David mentioned it's called the IDC, the data deluge. It talks about this, and you can read a lot more about this with that resource. So there's really two things. One is projected storage capacity growth is just far outpacing infrastructure spending, and that gap is only going to widen over the next 5 years. The second point is interesting, and it helps kind of provide the path here. And it's that of all that data being generated and stored, it's estimated that 60% of all that data is cold. Now, cold data is inactive data that's accessed infrequently. But an interesting point that one of our partners made is they said, yeah, but it's only cold temporarily. It's only inactive temporarily. And if I look at that pyramid and I think about digital transformation initiatives and AI and machine learning, a lot of the customers we have use cases where data is hot for a little bit of time and then it gets moved to cold. And then at some point that's hard to predict, they need to move it back into warm or hot storage because they may want to develop a new training model based on this massive amount of data they sold, this corpus of data they've built. And so we think that many large enterprises, any organization that's generating a huge amount of unstructured data needs to think about a cold storage strategy. And now many of the offerings out there that people could look at might be traditional file and object store systems. It might be the public cloud. But we don't think that all of those meet the needs of what's needed in the market. And we believe that there's a need for a new class or a new type of storage. So let's just sort of recap where we are so far. Massive data growth. Most of it is unstructured. Most of it is cold data. It contains immense value, and it contains potential for future reuse, right? Future ways to enrich that data further, right? It might be by adding additional metadata tags. It might be by finding new ways to use it in the future. It has to be protected because it's so valuable. It has to remain accessible, right? So putting data in a vault, for example, and just where it's not accessible, it's stored, but you can't reuse it, right? And really, we're seeing these timeframes with our customers where it has to be protected and remain accessible for years and for decades and sometimes longer. Public cloud is an option. It's expensive. The budgeting for that can be unpredictable if you don't know exactly when you're going to need to retrieve data from an archive in the public cloud. More so, many of our customers that are managing this data are reluctant to give up control. And although existing file and object storage systems, many of you are probably using that today for your big unstructured data storage, they're not economically suited to do this at the scale and at the longevity that we're now seeing. And so Quantum, we've introduced a new offering recently that I want to talk about a little bit. It's called ActiveScale Cold Storage. This is a new class of storage for ActiveScale systems, and it is S3 Glacier class storage that can be deployed in the data center of your choice. We offer it as a fully managed service. I'll talk about that more. Objects that are stored in ActiveScale cold storage can be retrieved in minutes. There's no data access fees. Now, because we're using tape under the covers, we're able to offer great economics. So great savings relative to public cloud cold storage services and up to 80% savings relative to a disk-based object store system or a disk-based scale out file storage system, which is what, again, many of you are probably using today. Because of the way we do erasure encoding on the tape, which I'll talk more about, we can offer much better data durability than any tape-based archive. So for some of you that may be archiving on LTO tape already, what we do here is very different. And I'll talk about the ways, some of the technology under the covers here, but we're able to offer much better data durability and much better storage efficiency. Now, we've made this very easy to deploy and very easy to manage. And I want to talk about kind of how we've done that. So this is really deployed as part of an ActiveScale object store system. ActiveScale is our object store system. Anyway, and the way the platform is designed, we can have a disk layer and we can have a tape layer. Now on the disk layer, that's really suitable for all the warm data. You can even do analytics on it and everything, and we can scale that from terabytes up to exabytes in size. If to access data off of ActiveScale on disk, we would, your applications or your developers, your users would use S3 standard, it's S3 standard class storage. Data access is almost instant, very high levels of durability, and we can offer this layer of storage as a fully managed service for $15 per terabyte per month, or about 0.015 per gig per month. Again, no data access fees. Now on the tape layer or the cold storage layer, we use S3 Glacier class to put objects to that tape and to retrieve objects from tape, right? So we actually just use the S3 Glacier API set. Data can typically be retrieved in minutes. Same levels of durability, so very, very high level of durability to practically eliminate the risk of data loss. And we can offer as much capacity as you need in that tier for $3 per terabyte per month. That's where we get the really amazing economic benefit and savings, and I'll show you a TCO here in a minute. Now, what are we doing here under the covers? Because this is very unique to Quantum. It's new, and we think it's really exciting. We've basically taken the architecture, we've taken our expertise of how to build cold storage at hyperscale, and we've packaged it with advanced ActiveScale software to be able to offer this entire thing to you as a service. We really combined two breakthrough innovations to make this possible. The first is what we call two-dimensional erasure encoding, or 2DEC, which is the way that we write the objects to tape in an erasure-coded fashion. I'll talk more about that. And the second is what we call a quantum rail architecture, where rail stands for a redundant array of independent libraries. In this case, again, we're using tape systems deployed in this rail architecture to achieve these new levels of performance, durability, and storage efficiency. So I want to talk for a minute about the technology under the covers. Now, the first breakthrough innovation here that really enables this whole thing, we call two-dimensional erasure encoding. And if you look at this diagram, it's referred to as two-dimensional erasure encoding because we erasure encode objects both vertically across a single tape or on a single tape, as well as horizontally across multiple tapes. Now, this is patent pending. The multiple tapes can be in a single library, or they could be in multiple libraries. So kind of explaining this a little bit more from left to right. Okay, as objects are written to cold storage, we start to build this aggregated container of many, many different objects, and we containerize it into one single big stream. We do that in a kind of free space on active scale disk. While it's there, everything's protected. It's fully erasure encoded and protected. We then package that up and we write it as a single erasure coded stream to tape. Why do we do that? For those that are familiar with tape, you know that you want to write data in big streaming chunks to tape, basically, right? But it's important to note that what we now write to that tape is a lot of different objects. We then have multiple independent streams that write across multiple tapes. This can be dispersed across multiple tape drives, multiple tape libraries, and those can even be in different data centers. So you can actually build a geo-dispersed archive. And why does this approach matter? The most important thing, one is you get these amazing levels of durability as you can with a disk-based object store system. But because of the way we do this, in most cases, we can retrieve an object from cold storage by only loading a single tape. And that's one of the reasons that this is such a breakthrough innovation. It really is what allows this to work. It allows you as an enterprise, or you as an organization that is generating and storing all this data, to be able to take advantage of the economics of tape without really knowing that it's even tape under the covers. Now, the second technology that we bring to market as part of this active scale cold storage offering, we call a quantum rail architecture. So rail, again, redundant array of independent libraries. Think about this. I think about the analogy of an old scale up disk system where you'd have a controller node and you'd scale up with JBODs, compared to a newer architecture, which is scale out, right? Multiple off-the-shelf servers. You've got that highly available primary storage architecture in that case. Similar analogy here. As opposed to having a single monolithic tape library that is often a massive construction project to deploy and to manage and everything, we can deploy the tape layer with multiple smaller systems. So we're scaling out tape. Now here you get a lot of benefits of this architecture, and this architecture really only works with the two-dimensional erasure encoding. You get better redundancy because here in this picture, there's 9 different robots working, right? There's tape drives in every system. So if a system's unavailable for some reason, we can still write objects to all the other systems, and we can still retrieve objects by basically rebuilding, if we need to, that erasure encoded object and then sending it back up. You get better aggregate performance because you can take advantage of all the robots across the stack. And it's a simpler design, right? They don't have to be contiguous. These can be deployed as a rack mount library. It doesn't have to be, a single data center aisle, and they can be deployed throughout your data centers, right? They don't have to be contiguous. So it's more modular, it's more flexible. So those are the two kind of breakthrough innovations. I wanted to spend a little bit of time on the tech under the covers. Happy to take questions on that as we go through it. Let's up level this and talk about why it matters. Because we're able to take advantage of the economics of tape, we can deliver some amazing TCO savings. And I'm going to really focus on relative to other disk-based storage systems, file and object storage systems. Now, what this is showing is it's comparing the total cost of ownership of storing 10 petabytes of cold data over 10 years. For this model, we've assumed that 5% of the data will be accessed per month. We can vary that because, obviously everyone's going to be different there in terms of their data access patterns. And then we compare a disk-based object store services or systems. We compare active scale cold storage at the bottom in purple. And then we're comparing to 2 different public cloud storage services. One is AWS Glacier, which is one of the most popular public cloud cold storage services. And we compare to Wasabi. Now, Wasabi is not really a cold storage service. It's designed for a different use case, but they have good pricing. It's $6 per terabyte per month. There's no data access fees. So we wanted to show it as a comparison point. Now, what this shows is that over those 10 years, if you keep everything on disk, it's going to cost about $18 million over a 10-year time horizon, whereas something with active scale cold storage would be just under $4 million. So the savings is about 80%, and it would represent about 14 million in savings over the 10 years. Now, we also have savings relative to AWS Glacier, about 34% in this model. That's going to vary. If you have a very active archive where you're really bringing the data back quite a bit, you're reusing it. Well, as we know, many of the public cloud services for this do charge for data access fees. So if you're accessing the data very frequently, the public cloud is going to be even more expensive. It is one of the benefits of active scale cold storage, which is there's no data access fees. So really amazing TCO savings. And again, just kind of summarizing and bringing together the offering, it combines, I think, the best of our active scale object store software and technology with our tape expertise. It's deployed as a single integrated system. Okay, so single namespace, single user interface, your developers, your business units, your IT team would just be interacting with an S3 standard API and an S3 Glacier API. Right? We have super high levels of durability, and we've done a lot under the covers to optimize how it works with tape. So a lot of amazing technology. And the next question that we asked ourselves, and the last thing I'll talk about, is we wanted to make this very easy to purchase and very easy to deploy. And so we offer it as part of a line of fully managed object storage services. And so these are our new object storage services we've rolled out. The way the services are structured, we can sell these or offer these for either active data or cold data. You can see the different data retrieval times. You can see some of the service level objectives in terms of how data is being accessed and the durability. And then we can offer this for this two-tier all-inclusive pricing model where it's $15 per terabyte per month for active data, $3 per terabyte per month for cold data, and again, no data access fees. So this is about offering a fully managed service so that if you want to purchase it this way, we've made it very simple. It's kind of about trying to bring that cloud experience to your data center, right? Now, you can see here, we do look for some minimum commitments when we do this. This is pretty typical of as a service offerings in the industry now. And you can see the minimum commitments for capacity and a 3-year term. And I think that hints also at kind of where we see this fitting best. I think if you have maybe 10 petabytes of data, 50 petabytes of data, 100 petabytes of data, I think this is a great fit for you. And I think you'd see some amazing savings. If you have a petabyte or a couple petabytes, we'll talk to you about, object store, and we can always add on the cold data storage service later. But this is really where I think these new offerings shine, is for those users that have 5 petabytes, 10 petabytes, growing to 20, 30, 50, 100 petabytes. And, in our experience, there's a lot of organizations out there that are dealing with that. So in summary, this will allow, if you're an organization that is dealing with this, right? These new offerings will allow you to address that massive data growth and reduce your cold storage spend by up to 80%. So again, we're helping to close that gap between data growth and infrastructure spend, right? While keeping the data accessible. It's going to allow you to preserve and protect the data cost effectively for the life of that data, whatever that is. It may be years, it may be decades, it might be longer. You get to maintain the control, you get to maintain the security. And because we make it so easy to access data and retrieve it out of cold storage, we believe that ultimately organizations that go with this type of a strategy, with this type of an architecture, are going to be able to unlock more value in their unstructured data and win in their field, whatever that might be. So to learn more, I've listed a URL here. You can go to our website, quantum.com. We have a product page that talks about ActiveScale cold storage. We have a lot of assets there, a lot of different resources. We even have videos that show and illustrate, how two-dimensional erasure encoding works. If you do go to that page, or if you go to our website, please engage with our chatbot. Our little chatbot will come up, mention this webinar, and that will really help our team to make sure that we get in touch with you, and we can have the most relevant conversation right away. So with that, let's take questions. And David, back over to you, and we'll take some questions. So.
Excellent. Yeah, great presentation, Eric. I learned a lot about this. This is really cool what you all are doing there at Quantum. Some cool new acronyms as well. I learned RAIL, erasure coding on tape. So cool stuff. We've got a lot of great questions coming in from the audience. I'll take this first one, I guess, from Warren, who's asking, how fast is quantum tape recovery speed compared to disk recovery?
Yeah, so if an object is being retrieved from tape, it will typically take, I would say, a few minutes. We usually say minutes. Now, retrieving an object from disk happens almost instantly, right? As you guys know. So from disk, it's almost instant. From tape, could be anywhere from under a minute to maybe, several minutes. And one of the questions I've had a lot is kind of walking people through that process. Because of the way we do the erasure encoding, I mentioned that in most cases, we can retrieve an object from cold storage with just a single tape mount. So, the command goes, get this object, right? Using this S3 Glacier command set, get the object. The robot goes and grabs the tape, loads it into the tape. The tape's either rewound or fast forward to the point of the data stream where we need to retrieve that object from. And then that object gets put back on disk. And I didn't mention this, but one thing I'll just expand on, the way the S3 Glacier command set works, retrieving objects from an S3 Glacier class storage happens in two steps. First, the object is put onto a landing zone effectively. And then at that point, the object can be moved to some other place to be modified or changed. So that's exactly how we've implemented our system.
Okay, yeah, and for anyone who's used like S3 Glacier before, it's the same way. It's you're a little nervous the first time, but then after that, it just works every time. It's amazing.
It works. And we have tried to, we've tried to mimic that experience, on an on-premise solution, basically, or a private cloud solution. Yeah, go ahead.
Awesome. Let's see, another question here. George is asking, what about the health of tapes over time? Like, do tapes that have aged at some point need to be replaced with newer tapes?
Yeah, it's a great question. Let me bring up this Rail architecture diagram if this is helpful. We do some really unique things here to monitor the health of the tapes. The first thing I would point out is in this architecture and in the architecture that we've deployed for some of these large hyperscalers, the tapes stay in the library. It's different. So a lot of people think about tape. They think, they make a copy of data to tape, take the tape out of the library. Now you've introduced contaminants, right? You've got a human touching it. They put it in a cart, And I think a lot of times over the course of the last couple of decades, tape has gotten maybe a bad rap because it goes through that process and then they can't recover data from tape. So first is the tapes stay in the library. Okay, so they're in a controlled environment. It's in a controlled environment for humidity, for temperature. We have software in our tape library systems that actually will periodically monitor the health of the tape. We can do that through a few different ways. We can do that through, checking stats on the cartridge media chip. We can even do it through kind of loading a tape and doing a a fake read, if you will. So we're looking for degraded sectors on that tape. Now, tape, when it's kept in a controlled environment, um, it is the most reliable media for keeping data for many, many decades, and that's been proven. And that that gets into physics and that. But so we think that if you're going to be keeping data for a long period of time, tape is the most reliable medium to do that on, especially if we can keep it in a controlled and a contained environment here. And that's what we do. Lastly, think about this. Because we're erasure encoding objects in 2 dimensions, we can actually show that for a larger archive, you could lose up to 3 tapes and not lose any data. I mean, that's the power of the erasure encoding, right? It's kind of like if you're familiar with erasure encoding on disk, and you can lose disks, but you can still rebuild the object. And that's exactly what we're doing here with tape. So I think we've really mitigated almost any of the risk of data loss because of the combination of keeping it in a controlled environment and doing that erasure encoding.
Yeah,
Great
that's
question.
very interesting. Yeah, keeping the tapes in a controlled environment like that to prevent potential damage to the tape, and then monitoring the tapes over time. So here's another good question, and it kind of goes back to the ransomware, air gapped, concerns and questions that folks have, and they're asking, would this be a good solution to air gap our data to ensure that it doesn't get infected with ransomware?
Yeah, I think it is a good solution. One of our large customers, the reason that they articulated that they really, one of the reasons they articulated that they really wanted to use tape is that it is cyber resilient. We're starting to use that term a little more. I've noticed the industry is starting to use that term a little more. And if you want to build a cyber resilient infrastructure, particularly for archival data or cold data, I think tape is really well suited for that. Quantum, I would encourage you to look at our tape systems. We do some very unique things around data security and cyber prevention that no one else in the industry does on tape. I didn't talk about it in this presentation, but we can combine some of those capabilities with this solution offering to build a cyber resilient data archive. And I think that's going to be a chief concern point and consideration over the next 5 to 10 years. David, I mean, as you guys know, we've done some panels on that too. So
Absolutely, yeah. Huge concerns, and this seems like a great solution. Jim is asking, will the data on tape be encrypted? Is that part of this solution?
It can be encrypted. We would leverage the encryption that's, let's say, built into the LTO tape drives. And so that is a possibility. So yes, the data is somewhat encrypted anyway because it's erasure encoded, right? I mean, you've got to kind of undo that erasure encoding algorithm. So there's a measure of that, but yep, can
Okay.
be. We're going to be really building out the capabilities of that over the next couple of years. I know, just because cyber prevention and just the security is such a hot topic. I mean, it's such a chief concern. So
Absolutely. David is asking, as new medium becomes available, are there methods or mechanisms to help migrate from the current media to new media, to not only keep the media fresh, but to increase the capacities?
yeah, we have ways to do that. I'm going to explain that by another analogy to a disk-based object store system. So when disk-based object store systems came out, they might have started at, oh gosh, I don't know, maybe it'd run on some disk systems that had 12 terabyte hard drives, right? Well, then 16 terabyte hard drives came out, and then now 18 and 20. And with a disk-based object store, you can deploy a new server node with 18 terabyte disks next to your 12 terabyte disks, and the erasure encoding will kind of move those objects and move them into the higher density disk. Same concept here. You might start with libraries that are filled with LTO8 media using LTO9 drives. And then maybe as the price of LTO9 media comes down, you might deploy another library next to it with LTO9 media, right? Because we have the erasure encoding software that knows where all the bits and bytes are stored on tape, we can spread that out over time. We can migrate it. And so that's one of the, one of the big design requirements and considerations for us is we anticipate that we will have customers that will want to keep this data for many decades, which means you need to have provisions to be able to migrate and take advantage of those newer generations of LTO. We're also starting to look at DNA storage. We're a member of the DNA Storage Alliance, but that is probably a topic for a different webinar. So, that's many years out. But we think that DNA storage holds a lot of promise for archival data storage in the next couple of decades.
Absolutely, yeah. I would love to do a whole webinar on that. That sounds fascinating.
Yeah.
Paul is asking about if Quantum is using high density tape options, or maybe exactly what density or what level of tapes are used in these solutions.
Yeah. Our tape systems support LTO tape technology. Quantum is one of the members of the LTO consortium, along with IBM and HPE. So the current generation is LTO9. And these tape systems support LTO9 all the way back through LTO6 and prior. LTO9 tapes, I believe, have 18 terabytes of capacity per tape. And if you go to our website and look at our tape systems, the design of the tape library itself is very high density. So we do not support the proprietary tape drive from IBM, but because of the way we design the tape library, we can hold, I think, up to almost 1,000 tapes per rack. And when we deploy it in this rail architecture, we actually can get the best storage density for tape if you measure it on sort of like a capacity per square foot basis. It actually is the best density in the market if deployed in this rail configuration. It'd be if there's any interest in any of these questions, please reach out to Quantum, because for example, we can sit down with you and do a side-by-side density comparison as we've done for some of our big customers. So, these are all fantastic questions, and we're happy to go a lot deeper in this. So let's keep going.
Yeah, absolutely. There's a couple of questions here kind of around whether or not Quantum has a solution, or if you partner with someone perhaps to identify or prevent malware being stored in the library, or ransomware encrypted data being put into the library.
Yeah, we don't have any direct integrations or partnerships with any of those types of vendors today. There are a lot of them out there. We think about cyber prevention as kind of being, in a simplistic way, it's kind of like the front end and the back end. And this doesn't really help with front end prevention, right? Obviously, which is you want to be scanning your network. If you detect that someone's trying to hack in, you can there's softwares that can detect that. What we plan to do on our roadmap is there are some ways where you can detect signatures of if someone's trying to corrupt data on tape, for example, we can detect that. I think that's where we're going to build some more AI capabilities into our software. But what I would advocate today, and this is a common question we get, if you have data that's been corrupted and then you write it to cold storage, all you're doing is saving a corrupted version of the file to cold storage. And so tape doesn't help. We're advocating to make a copy of data and keep it here and do that often. Um, some of our customers in media and entertainment, when they are working on a feature film, they use our file system, which is called StoreNext, and it has a policy called copy on ingest. And the concept there is you upload a brand new file and immediately you make a copy of it to tape. So now you have a pristine copy sitting on tape. Now it's not using this tech, it's not erasure encoded, but I think the concept there is important for cold data storage where it's like you've got your data, make a copy of it and keep it there. Because if you know you have a pristine copy on cold storage, it is very secure. And I had this question asked by one of our customers in the federal space. This was a great question. He said, if I bring an object back from cold storage, does the pristine copy stay in cold storage? And actually, the answer to that's yes. We keep a copy of that object perpetually so that when their question was, this was someone that was working in developing AI and machine learning models. And they said, they would bring an object back from cold storage and then they would want to modify it and then eventually write it back to cold storage. And that is happening all the time. And he says, well, if I bring it back to warm storage, for example, it's now kind of exposed. It's at more risk of maybe being corrupted with malware. And so I had one of our technical guys look into it, and it's like, yeah, if that happens, you still keep that pristine copy on cold storage. So you might have lost the work you did, but you've got that pristine copy. So think about that as you're thinking, and that's true of backup. For those of you in IT or managing backup, think about your RTOs and your RPOs, and with the threat of ransomware, how often do you want to make a copy of data to tape? And I think we can help, consult through that as well. Our teams can. So,
Excellent. Question from Paul: does Quantum have any solutions for smaller IT organizations for cold storage?
Yeah. We have Quantum has about 11,000 customers around the world, and a lot of those might use a small tape library or a backup appliance. This particular solution I'm talking about today, it really is designed for organizations with many petabytes of data. But if you look at Quantum's portfolio here, for smaller businesses or for utilities, smaller backup environments, smaller IT organizations, we have a huge customer base that use a single tape library, for example, for offline storage. Those start at 3 rack units and under $10,000, and you can get any more. Within 3 rack units, we can do over 500 terabytes. So it's a lot of data. So yeah, backup appliances, we have a lot of those deployed around the world. Surveillance solutions, we can do any size, and then our file system is used a lot for maybe small post houses. We have a lot of organizations like in universities that might be developing training content on it. We've got a lot of customers in, athletics departments and sports and everything. But yeah, our portfolio kind of runs the gamut.
Excellent. A solution for everyone. I like that.
Yeah.
What about Jeff is asking, is there a way to air gap the tape data so that hackers cannot delete what's on the tapes? Like write once, read many type of thing.
I'll see if I can share a link or something. We just announced a feature of our tape systems that we call ransom block that does just that. It is unique in the industry. It came out a few weeks ago, and I'd encourage you to check that out too. So if you go to quantum.com and go to tape storage, it's pretty prominent where we show what we did there. We developed that feature in conjunction with one of these large cloud providers, and we're going to basically integrate that capability with ActiveScale cold storage on our roadmap. What that feature does is it basically creates a physical block between the tape robot and the data tapes that are sitting in the system. So even if you have someone that hacks in and controls the tape library and is trying to retrieve data, we prevent that from happening with a physical barrier. It's very clever, and maybe that's another webinar we'll do. But yeah, I'd encourage you guys to check it out. Yeah, we do have a way now to prevent that, so that even if someone were to hack into the system, the tape library, the data that's on the tapes can be protected and secured.
Very cool. Very cool. Question from George. He's asking, you mentioned that the tapes are stored on premises in the library. If folks want to get that cold storage data offsite, what's the best solution for that?
We can do a couple different options there. One is the active scale. Remember that the tapes are really part of an active scale object store system. And I could, let me bring that diagram back up just to talk to that. Active scale can replicate buckets to the public cloud provider. So if you wanted to just replicate certain buckets to AWS Glacier, and you wanted to just keep that copy there for offsite, you never intend to, access it, the software can do that. So that's one option, would be just replicate buckets to a public cloud. The second option would be, if you want to deploy an active scale cold storage environment and you want to put, let's say, 3 tape systems at 3 locations, maybe it's your data center, a colo and Equinix, and another data center, we can do that. And in that case, your data is protected because of the way the erasure encoding happens. You could lose a full site. We can still access all the objects that are stored on tape by rebuilding the objects from the tape systems at the other 2 sites, just the way that active scale works with disk. So you got 2 options there. In a larger environment, we could deploy it as kind of a geo-dispersed model for that multi-site protection. Or if you want to just replicate buckets to AWS Glacier, the software supports that.
Okay, I like that. Yeah, a lot of different options.
Yeah.
Kayla is asking, is there a way to search through the cold backup for PII, personally identifiable information, and delete that information to comply with regulations like GDPR or CCPA?
Yes, great question. One use case for this would be if you use it with a backup application. Any backup application like Veeam or Commvault or NetBackup, if they support S3 Glacier, which now many of them do, they can integrate into the system. Now, I don't know if some of them are able to look for personally identifiable information. I'll have to go look into that. If the files are video files or image files, Quantum has software that we call CatDV, the asset and workflow management software, that can actually go index the objects in an object store and look for specific tags like that. So it's usually, I don't think we have customers using it for that purpose, but it would work that way. That's a good question. I'll do some homework on that one too, because I could see the value in that for GDPR, and even I don't remember the new California regulation, but that's a key consideration.
Absolutely.
Good question.
Yeah. And then I think you kind of covered this one, but it might be good to just review it. They're asking, is this only available as a service?
Oh, no, we can make this available as a product, in which case you would purchase ActiveScale software and then purchase the tape hardware and the disk hardware separately as separate line items. So we can offer it that way. We've had some customers that are service providers who kind of prefer it that way, and then they're using it as the basis for their own service. So we can offer it as a product. We believe that most customers will want to purchase this as a service just because of the simplicity. And we can just say, and just walking through that, it's like, in that case, we'd say, okay, subscribe to the service. We'll size the system for you. We do all that work as part of our consulting as we're setting up the service. You purchase it. We'll deploy all the hardware wherever you tell us to deploy it. Quantum owns all the hardware, and we get you to the point where your users are connected to the system. They can see buckets, and we give your developer the S3, the API guide, right? And they can start coding. Now, in that, as a fully managed service, we handle all the parts replacement. If a tape drive needs to be replaced, we handle that. If a robot goes down, we handle it. And you should just view it as you'll have an SLO, and there you go. So we think most customers will want to purchase it as a service. That's why we've productized it that way. We can offer it as a product if people would prefer.
Okay. Okay. Excellent. Well, Eric, I think we've covered most of the questions out there we really have time for. This seems like a good place to wrap up. Thank you so much for educating us on, what Quantum's doing around cold storage. This has been really interesting. Thank you so much.
Yeah. Thank you. It was great. Thanks for the time.
Absolutely. Yeah. And thank you to everyone out there in the audience for all the excellent questions and for joining the webinar today. Don't forget about the resources there in the handouts tab. There's a resource there from IDC called Data Deluge, Why Every Enterprise Needs a Cold Storage Strategy. Excellent resource. And then also a solution brief on the Quantum Active Scale Cold Storage solution with additional details beyond what we talked about on the webinar today. So make sure you download those and check those out after the event. Before we wrap up, I, of course, do want to announce the winner of our Amazon $300 gift card door prize. This is going out to Tony Hardgrove from Pennsylvania. Congratulations to Tony. And we will be reaching out to our best question prize winner as well. Again, thank you to everyone who asked all the excellent questions. We had a really active audience today, and we appreciate that. Hope that you learned a lot, and check out quantum.com for more information. See you next time. Bye-bye.